Hello everyone, we will solve this today's LeetCode problem. This is LeetCode medium. This is some root to leaf numbers. Let's see what is this question. So this is we are given a root of a binary tree containing digits from 0 to 9 only, and each root to leaf path in tree represents a number. So the root to leaf path is 1 to 3, which represents the number 1 to 3. So, and also the main thing is to notice the test case are generated so that the answer will fit in 32-bit integer. It means we can store, we don't need to take a long type answer, right? So what we need to do is we need to make a number from root to leaf, and the, the total number of numbers which are made by using root to leaf numbers, we need to add them all. Suppose in this, from root to leaf there will be 1 2 which is 12 and 1 3 which is 13. 12 plus 13 is 25. Again in this 4 9 5, this is 1 4 9 5, then again 4 9 1 which is second, and 4 0 which is third. So we will add all three, which is comes to 1026, right? So what we are doing here. So first first we have whenever I need to go to root to leaf, it means I need to iterate in I need to iterate in this whole tree, right? For finding all the root to leaf nodes. So what we need to do, we will use a DFS approach here, right? What we'll use, we can use also DFS, and we can also use iterative approach, right? So let's see first DFS approach, which is also recursion. So let's see DFS approach here. So here this is given 49015. So what we will do, we will move to every root left and root right value. I will again move to its root and left value, and whenever I get a leaf number, I will simply add my I will move to this root value left and right, and store the string value, store the string to the same with this 5, and do again and again, and go whenever I encounter any leaf node, I will add that current string number in this. So what I mean is, suppose here is given 1, this is given 2, now this is given 3, right? So here this is given, so from I will start from 1, and I will insert in my string this 1, right? Now I will move to its left, and I will also insert this 2 in my left, so this becomes 12, right? If this becomes 12, so, and it is also a leaf node, so I will add this in my answer, right? I will add this in my answer. Now I will pop out from this string and move to this 1, and now again I will move to its right, it becomes 1 3, and I will add again this 12 and 13 in my answer. If there is a node and which is equals to 25, right? This same goes with everything. So what I will do is I will make a add variable here, and I will call a solve function here, or take it as a DFS, that take it as a root and a string. I will pass a string and a root value. So, and I will when I solve this, this string is, let's temp. Now what I will do, first I will push this root value in my temp, right? I will push this root value in my temp, then I will check whether this root left exists or not. If it is exist, I will push it into, sorry, I will call this function root left, and this will be the temp value. Again, for same thing for right. Right. So when will this recursion will end? So when my root when I will get encounter a leaf node. So leaf node condition is that both of this child is should be null. So whenever I counter this, I will first push, I will first push this root value here, and then I will add this current temp in my answer, and I will return it, right? I will simply return it. Okay. Also, when I have posted it, okay, yeah, so I will return it. So if I make it as a and by reference, by because it will always make another copy. If I pass by value, if it will make another copy, and that will take extra time. So if I make this as a temp, so I need to also pop it up whenever I will backtrack this, right? I will backtrack this simply. I will backtrack this. Now let's run. Okay, I need to return answer also. So let's see. DFS root. DFS. Okay, sorry. I need to pass it here. Oh, okay. So one thing here, that before compilation we should always check whether we have written correct or not. Uh, that will create a good impact on you. And valid argument is toy. A runtime error. Let's see what is going on. I have moved to root to left, then root right. What is this temp here? Is this greater than this answer? Oh, okay, this is a string, right? So I need to push it in characters. Yeah, this is a string, so I need to put it in characters. Yeah. So the problem was here that the problem was here that we need to just, okay, so I can also pass it like this, the previous approach. This will also fine. This is not a hard and fast rule. This will be also fine. This should also fine, I think. Why this is not working? I think that should also be fine. why is that not working? Because I have passed using pointer and I will not iterate. Okay, yeah. So the problem was that I was passing pass by reference, so it was not assigning. It was not able to point any of the previous memory because we haven't defined that temp, and I just was just passing the empty string here, right? So we need to make a memory for pointing this by reference, right? So here this is how you can do it by reference. So let's submit it. uh, let's see if I will get memory limit exceed, because this is 1 to 1000 and this is 9. So every time I uh, use a temp variable to store in it, and always decrease it. Let's see what happens. So yeah, it is passed. It is, we have passed this already. So what is the time complexity? That will be O of O of n is number of nodes here, obviously, and also we are taking temp as a variable, and that will that can contain approximately at most 10 value, which is this 10, right? At most 10, because the depth of the tree will not exist 10, so temp value will be always less than 10, because at the time I can only insert a character from a label, right? Because I have been popping out always. So yeah, so this is a recursive approach here, and so this is a recursive approach. So now let's see how we will do uh, by iteratively. So in tree, what we are doing, we are moving, if you see, we are moving in pre-orderly form: 4, 9, then 5, then reverse it, then 1, then reverse it, then 0, right? And whenever I get a leaf node, I will add this and answer. So for a pre-order, what we do, how will we print out pre-orderly in iterative way? So if you see, we will move to 4, we need to go to 9, we will go to 5, then we need to reverse it, we need to go to its previous value, then we will again we will go to its right value, then we will again go to its previous value, we again go to previous value. So for going to previous value, how will you uh, move to its previous value? By storing that node, and by storing the last node. And how will you move to the last node, right? You need to use a stack value, because a stack is a last in first out. So for move to its previous value, we need to stack, and so that I can move to its parent value, and then we can iterate again to its right or left children's, right? So what I do, so suppose it is given 4 here, this is given 4, this is given 4, this is given 9, this is given 5. Now this is given 1. Now this is given 0, right? So what we'll do, I will use a stack, and I will see whether I will move to a stack, and I will insert this 4, right? And along with this 4, I will also insert its value, like along this 4 I will also insert this string, right? So this is 4 again, and I will store this 4 with the string 4. Now again move to this 9. For this 9, what will the string value, which is equals to 49, right? Which is equals to 49. Sorry for this, but I can't do this anything in this case. Okay, so this will be equals to 49. So this is equals to 49. Now this is something called 0 and this string is 40, right? Now when I come to this 5, this becomes 9. Same approach, like we have done in this. We are moving towards root left and this root right and inserting this. Instead of DFS, I will just push it in my stack value. So what will I change? I will make a pair value, tree node string, and this is stack, right? And let's make an answer here. And first I will push a stack value in this, that will be this root is comma 0, right? And I will move till where this stack is not empty, and I will just iterate like this fashion, which is we were doing in a string, this in DFS. What we are doing, we first push this. So just copy this and paste this here. So what we are doing, we will take this node, take this node and temp string, and just take a top value and pop it out. Now what will I change? This temp dot pushback node value should be inserted. Now we'll move to this node left, and instead of DFS I will push this node left with my temp value, and again for right value the same thing, this node right and this temp. So if you see, and when I need to also insert first this character, whenever I get a leaf node, I will add this in my answer. So I need to maintain this node right. This node value should be inserted. Now this style will be temp, and this will be we will continue this, right? We will continue this, right? Or we can do this like this. This should be at the top, and remove this here, right? Now answer should also be the same. Node left, oh okay, this should be in pair, right? This should be in pair, this should be in pair. So this is how we will do this. Let's run this, right? First we will run this. Let's check whether it is correct. I think that is correct again. Yeah, we have passed it, submitted. Yeah, we have passed it. But here you see we are inserting temp value here, which can contain 1 to 10 always value. So instead of temp we can also use an int variable, right? How we can do like this? We will use a string, and we will just use a because it can be possible that a string can take more characters, more number of memories than int value. So we will not insert the string value always. So what we will do, we will insert int variable. How? Let's see. This node value should be inserted. So this is to combine all the numbers within, and then I will simply add this number to this, just this approach. Let's run. Yeah. So this will take less memory than previous, because previously we were storing, see, you can see almost that it will uh, changes the time complexity and space complexity, because previously we were storing whole string in my pair, but now I will store only int variable. So here is the change. So what will the time complexity of this approach? It will take O of course n, and in worst case it will take us space as a O of log n, because the stack need to need to insert whole tree, right? So in iterative way, the time complexity will be O of course n, and the space will be O of log of n. Log of n is height of tree, height of tree, and this is n is number of nodes. Right. So here we go, and this ndfs function, what will the time complexity? That will be O of n for whole node iteration, and O of n again for recursion stack, and the space will be, again the space will be the same for this string. What this string means, this string should be we need to treat in whole, so I need to maintain a string that will be O of, again, log of n, right? So from this time to we will remove iteratively in recursion stack, and yeah, this is how we can solve this DFS and iterative way both. So yeah, thank you, bye bye.